refresh your memory on some complex numbers today. So remember, the imaginary unit is equal to the square root of -1, which means if you square it, I squared gets you -1. Complex numbers have a real part and some amount of imaginary units to them. Complex numbers can be like strictly real numbers, strictly imaginary numbers, or a combination of both. And then if you are simplifying something that involves a square root of a negative, then before you do anything else, you need to go ahead and turn it into I times the square root of that number. Okay, so first thing, think of this as -1 times 81 inside your radical, and then you know the square root of -1 is equal to our imaginary unit I, and then square root of 81 is 9, so this just equals 9 times I. 48 isn't a perfect square, so I know I'm going to need to make a factor tree and break this down. Okay, so I can make this I times the square root of 48, and then since I have 48 is 4 times 4 times 3, I can take the square root of that 4 times 4 and get a 4 on the outside, 4i square root 3. Now it's important on this one that the first thing that you do is go ahead and turn these into I times the square root of 7 and I times the square root of 5. Do not multiply them together first and make it a positive 35. Order is important. So I brought my i's out, and then I'm going to multiply. I times I gives me I squared on the outside, and then I have a square root of 35. I squared equals -1. So what this is going to end up being equivalent to is just negative square root of 35. Same thing here. Need to go ahead and make this into I times the square root of 17 over I times the square root of 34. The i's are going to divide to give you just 1. So that's kind of nice. You'll just end up with square root of 17 over square root of 34. We could rationalize by taking it times square root 34 over square root 34, but I'm actually going to do something different and reduce my 17 over 34 to 1/2 so that it's a little bit smaller numbers when I rationalize, and then I'll end up with square root 2 over 2. We're going to switch this into standard form, which is your real part plus your imaginary units. So do that. Let's go ahead and make that square root of -200 into I times square root 200, and then break down 200 into its factors. Okay, so we got a perfect square factor of 10, and we can make that into 10i times the square root of 2 all over 5. So since my 3 terms share a common factor of 5, I can go ahead and divide by 5 and simplify my fraction a little bit. So I'll have 2 minus 2i square root 2. We're going to look at some powers of I besides like I and I squared. So we already know I is square root of -1 and I squared is -1. If you do I to the third, you can think of it as I squared times I, which gives you -1 times I for -I. I to the fourth you could think of as an I squared times an I squared and end up with a -1 times a -1 is +1. There's lots of different ways you could break these up. I could think of this as like I to the third times I squared instead of I to the fourth times I. If we keep going here, I to the sixth, I'm going to do it as I to the fifth times I, which I to the fifth was I, times another I would give me I squared, which is back to -1. And then I to the seventh, I'm going to just use my previous one again. I to the sixth times another factor of I to the sixth was -1, times I gives me -1. I to the 12th. I'm going to use I to the sixth times I to the sixth, since I just did that one. I to the sixth was negative, so that'll be -1 times -1 gives you +1. If you look later in this video, I have I to the 12th wrong because I had to go back and fix it. So it's +1. I to the 102nd power. Oh, I'm not going to complete this chart that far. Let's think about patterns that we notice. So if you look at these first 4 powers of I to the 5th and I to the 1st came out to equal the same thing. So did I squared and I to the 6th. So did I to the third and I to the seventh. And if I was to do I to the eighth, I to the fourth times I to the fourth would give me just a positive 1 again. So really we're just cycling through this pattern every 4 factors of I. So what I find easiest is if I break my power of I up into factors of groups of 4, so like break it into the I to the fourth, since I to the fourth equals positive 1, that's easiest for me. It's not the only way. So I'm going to think about how many I to the fourth I can make out of I to the 102nd power, because then I'll have a bunch of those that are all equal to 1 and some factors of I left over that I can simplify and see what this equals. So let's think about how many groups of 4 factors we can make out of 102 factors of I. So if I divide by 4, I can make 25 groups of 4 factors of I, and then there are 2 factors of I remaining left over. So I can think of I to the 102nd as I to the fourth 25 times an I to the second. I to the fourth 25 times is just 1 25 times, so I just have my I squared equals -1 for my extra factors, and then I to the 102nd is just equal to -1.